Hello everyone, this is Rui PCB, your trusted PCB partner. Today, we will explain the difference between the cut layer and the major layer in KICD. We often see people asking about the purpose of the major layer in KICD and how it differs from the board outline layer. Although the major layer can be completely ignored in practice, understanding and using it appropriately can bring certain conveniences to your design. Let's first take a look at which one is the major layer. It's this one, the purple layer here, and this is the board outline layer. First, let's look at the definition of the board outline layer. In KICD, closed shapes, straight lines, or circles on the board outline layer are regarded as the physical edges of the PCB. The copper pour algorithm will stop pouring copper when it reaches the shapes on the cut layer. The latest push and shove router does not allow traces to cross the borders on the cut layer. The purpose of the cut layer is to meet the requirements of PCB manufacturers and to define the physical outline of the circuit board. Some manufacturers require the board outline to be shown in the Gerber files of every layer, while others require the board outline to be displayed separately in a single Gerber file. KICD's drawing menu provides options to support both of these methods. Some board manufacturers prefer all internal cutouts and slots to be defined on the cut layer, while others may want this information provided in a separate file. Therefore, before manufacturing the board, we need to first understand the manufacturer's requirements regarding these aspects. In KICD, the major layer is a process term without a precise definition. I would say it doesn't really have a true definition at all, but that might not be entirely accurate. According to information from developer emails and forums, the major layer was originally used to define the setback area required from the physical edge of the circuit board, where no components, traces, or other electrical objects are allowed. Let's take a look. In this diagram, this is the board outline and this is the copper pour. There is a certain setback between them, but now you can also set this setback value in the board outline layer settings. Let's take another look at the function of the board outline layer. In addition to drawing the outline, some manufacturers also require that holes and slots be defined using this layer. So let's see what impact it has. First, we select the board outline layer, then choose to draw a rectangle, and then let's see what actual effect it has. After I finish drawing the rectangle, let's view it in 3D. We can clearly observe that a rectangular slot has been precisely made at this specific position. This is indeed the actual visual effect that the cut layer produces on the printed circuit board, or PCB. Next, let's take a look at the major layer and see what effect it has when we draw on the circuit board. First, let's undo the previous action, then select the major layer, choose the rectangle tool, and draw another rectangle at this position. Let's update the 3D view again. As you can see, there is no difference in the 3D view. Why is that? Let's go back to the PCB, press B, and reroute. At this point, two shapes appear on the PCB, and there is no difference between the two layers. Both the major layer and the cut layer have turned black. Now, let's see what the difference is in the 3D view. This is the difference in the 3D view. What is the effect of the major layer? It shields the copper, but the board substrate is still there. It doesn't create a slot at this position. That's the main difference between them. And then, what effect does this major layer have in DLC? When the board outline layer or major layer already exists, the router will prohibit routing across these two layers. Let's see if that's the case. Let's select the line tool and pick a trace. As you can see, we can't draw a trace within this layer. The effect is the same for both. They both result in a restricted invisible effect. So, what exactly happens if we carefully place the major layer in an area that already has existing routing in place? Let's draw one. place it here. Let's proceed to perform a comprehensive design rule check. Please allow it to fully complete. It gives an error. It prompts us. You can't route traces under the major layer. For our actual checks, if we use the keep out rule or a rule area, we can achieve the same effect. However, setting up a rule area is relatively more complex, but it can restrict more areas, more layers, or even include things like power nets. The major layer mainly restricts electrical area traces and copper pores. If you have a multi-layer board and want to restrict routing or copper pore in a certain area, you can use this major layer. The definition and function of the major layer are not particularly precise. Because of the existence of board-to-board spacing rules, most designs can be completed using only the board outline layer, and there's usually no need to use the major layer. However, in certain applications, using the major layer in combination with DRC can quickly determine whether there are unnecessary electrical objects within a specific area. Of course, this can also be achieved using rule areas. That concludes our content for today. If you enjoyed this video, please subscribe to my channel for more content. Thank you all.